Another circuit from the past papers, and this is a fairly easy one. This is a natural response circuit with some initial conditions given. Initial state of energy storing elements given. V naught is, as given in the problem, 10 volt at t is equal to 0 minus, and this current is 2 amperes. So we have this 2 amperes and this 10 volts before switching. So we know this V naught of 10 volts is basically the voltage across this each element. So VC 0 minus and VC 0 plus are going to be same because of the capacitor effect, and IL, let us call this IL T 0 minus and IL 0 plus is going to be 2 ampere. But the question says R is not given. Question says for what value or range of values of R will the voltage Vt, same polarity, across the capacitor be underdamped. The question is the response should be an underdamped response. For underdamped case, for a parallel RLC circuit, we know that alpha is 1 over 2 RC for a parallel RLC circuit. For an underdamped case, alpha should be less than omega 0, underdamped case. And alpha is 1 over 2 RC. This should be less than 1 over square root of LC, and 2 RC square should be greater than LC, and we know that C should be greater than L over 4 R square. We have computed this earlier on. We need to find for R. So R square should be L over 4C, or in other words, R should be greater than plus minus square root of L over 4C, or maybe in other words you can say plus minus 1 by 2 square root of L by C. So for this situation, for this condition, from this condition we can find the range of values of R, and in fact in finding the range of values of R we did not need any of the initial condition on all this solution. So nobody has asked us to solve it, so that's it. So R should be greater than plus minus 1 by 2 under root L 0.2 over C 0.1 into 10 to the power minus 6, that is plus minus 1 by 2. 0.2 over 0.1 is 2 divided by 10 to the power minus 6. So we get this equal to 1 over under root 2 into 10 to the power minus 3. So not inside the square root, or this is equal to plus minus 0.707 into 10 to the power 3 ohm, because we are computing R. So R should be greater than plus minus 0.7 or 707, no decimal point here, ohm. And minus obviously is not correct, so we discard that negative value. So R should be greater than 707 ohm is the required range of values of R for which the circuit is going to be underdamped.